So in this sequence, we will detail the symbolic filing rule. We know up to now how to represent in a symbolic and unique way the marking classes. And the definition of the symbolic firing rule that applies directly to them will be the second and final stage to obtain the quotient graph. So the symbolic firing rule is such as the following. Before firing, we will decompose the dynamic subclasses in order to isolate the objects that will be used to instantiate the color functions to do the firing. So for example, if we have idle of Z and res as a marking, so that was our introductory example about processes going in the critical section. So we have idle of Z plus res as a marking with Z of size 3. So that was corresponding to the initial marking. We will decompose it into two. So this Z will be decomposed into two elements, Z1 and Z10. Z1 will be of size 2 and Z10 of size 1. This decomposition will separate the values that will be used for the firing from those that are not used for the firing. And in this case, we use only one for the firing, so that is the one that is in Z10. So Z10 will contain the chosen object in order to instantiate the variable x, and Z1 will contain those that are not used for the firing. Then the classical firing rule is applied, and after the firing, we group the resulting subclasses. So, if we take the philosopher's example, we'll start with marking, think of Z1 plus Z3, in which we have 3 elements in Z1 and we have 1 element in Z3, plus a fork in F of Z1. The 3 forks that are available, so with the 3 numbers corresponding to Z1, plus e of Z2, and Z2 containing 1 element. So that represents a marking where one philosopher, so the one in Z2 here, one philosopher is eating. There are 4 philosophers that are thinking, these 4 philosophers, and we have 3 forks that are remaining here that are the forks numbered with philosophers that are thinking, which are in Z1 as well. Okay. So what can we do? We first, as we said, we'll first separate the elements that participate in the firing from those that do not participate in the firing. So this set in think of Z1 plus Z3 will be split into Z10, Z11, Z12, and Z3. So we'll split into the individual elements, and we'll do the same for the rest of the marking. So since we had Z1 here and there, we'll find the same decomposition here and there, right? Then from this, we can have a philosopher that releases its fork, and the philosopher that can release its fork is the philosopher that is eating, so the one in Z2. So then the resulting marking will be the philosopher releases its forks, it goes back to the thinking place, and the 2 forks are put back in the available forks place. Therefore, in think and F, you have all the elements as in the initial marking, and when you group the classes together, you will find, you can write it as think of Z plus F of Z, and all colors have the same role there. And Z contains the 5 elements, which is this marking here. Then another possibility is for a second philosopher to take its forks. So let's assume that the philosopher in Z10 wants to take its forks. So in Z10, we have a philosopher that is thinking here, that has its fork available, and he has the fork next to him available. So it is this one, as we have numbered the classes one after the other. And he will go to it, so you'll find it here. Is not anymore in thinking, and the forks are not anymore available. And when you group all these classes, the result is such that in place think, you have 3 different classes. There are Z2, Z3, and Z5. So which were initially Z11, Z12, and Z3. You have a class in the set of forks, which is named Z3 now, and this class contains 1 element. There is only 1 fork available, and there are 2 philosophers eating, so Z1 and Z4. So now you have all possibilities that are represented in each dynamic class. So each of the dynamic classes has exactly 1 element. The other possibility is to have Z11 take a fork, take both of its forks, and you can see that what he wants to take, so Z11 is this one, it will take its own fork, and it will also take the next fork that is here. And you do exactly the same thing. So the same applies, and you obtain also another marking where 3 philosophers are thinking, 2 are eating, and there's 1 fork that is available. Okay, so at this stage we know how to represent in a symbolic and unique way the marking classes, how to find from a symbolic marking a symbolic instance in order to obtain the symbolic successor. So what remains to be done is to derive the algorithm in order to construct the symbolic reachability graph, and we'll do that in the next sequence.